In this video, we're going to look at reviewing fraction skills to help with your Math 10 course. So why is this important to you? Well, there are a couple of reasons. First of all, we actually use fractions in a lot of everyday things. For example, baking. What if your favorite cake recipe requires 1 1/3 cups of flour, but you only need to make a half recipe? Or construction and design. If you're putting some trim around a room, we need to be able to figure out how many pieces of 5/8 inch trim do you need. In terms of this course, we also see fractions in terms of graphing lines and slope. And if you're a student who's going to take pre-calculus next year, you're going to see fractions when you have to do things working with certain expressions and equations, like this example of simplifying. So to get started, one of the most basic things we need to know is that fractions show us division. 3 divided by 5 can also look like the fraction 3/5. When we talk about fractions, we talk about a numerator, which is the top part of the fraction, and it tells us how many parts we have. We also talk about the denominator, the bottom part of the fraction, and it tells us how many parts it takes to make up one whole. Another thing that's useful to keep in mind with fractions is that anything divided by 1 equals itself. This is useful because it means we can turn any integer into a fraction by giving that integer a denominator of 1. For example, 2 can be 2 divided by 1, or negative 113 is negative 113 divided by 1. Another vocabulary term that we see with fractions is equivalent fractions. These are fractions that have the same value. They're equal to each other. So for example, 2 divided by 1 is equal to 2, and 4 divided by 2 is equal to 2, and 12 divided by 6 is equal to 2. So these are all equivalent fractions. If you need to make an equivalent fraction, one really helpful strategy is to multiply by some helpful fraction that's equal to 1. Well, what do we mean by a helpful fraction? If we take a look at that example we just had, 2 divided by 1 was equivalent to 4 divided by 2. 2 multiplied by 2 gives us 4, and 1 multiplied by 2 gives us 2. There's an equivalent fraction. Or to turn 4 halves into 12/6, we can multiply by the helpful fraction 3 divided by 3. And notice that 2 divided by 2 and 3 divided by 3, well, those fractions are both equal to 1. And multiplying by 1 doesn't change the value, which is why these fractions are equivalent. We started with one fraction and multiplied it by 1. We didn't change its value. It's almost like we gave it a Halloween costume. So taking a look at this from a slightly different perspective, let's say that we know what denominator we want to end up with and we're trying to find the numerator. Well, let's see, 16 multiplied by something gives us 48. Maybe you're really comfortable with your multiplication facts, or maybe you do a quick division to find out that 48 divided by 16 is 3, so 16 multiplied by 3 must be 48, and I'm going to multiply my numerator and denominator by 3. I'm multiplying by the fraction 3 divided by 3, which is equal to 1, so we're not changing the value. And we find out that that numerator now should be a 9. Another term that we should recognize for this course relating to fractions is the idea of lowest terms. A fraction in lowest terms is also called simplified or reduced, and that means the equivalent form that uses the smallest possible numbers. So let's take a look at the fraction 12/6. This fraction has an equivalent form that uses smaller numbers. We can divide the numerator and denominator each by 2 to get 6/8, and that in turn can be reduced to become 3/4. Some students may also know we could have gotten to 3/4 a little faster by dividing our numerator and denominator each by 4. Here's an example where knowing our multiplication facts can help speed up our work a little bit. Another term that we should recognize is the idea of a mixed number. A mixed number shows us how many wholes and how many leftover fractions there are. For example, 5 and 9/16 means we have 5 wholes and 9/16. Each one of those 5 wholes is 16 pieces, so we could figure out that those wholes, 5 groups of 16 is 80. That first 5 is a whole number, represents 80/16. We add that to the leftover 9/16 that we have. This mixed number could also be written as 89/16. And that's an example of an improper fraction where the numerator is larger than the denominator. If we're going to convert from an improper fraction to a mixed number, well, that's actually pretty easy. If we take a look at the example of 27 divided by 5, maybe you think about your multiplication facts and you realize 5 groups of 5 is 25 and 5 groups of 6 is 30. 27 is somewhere in between, so this should be 5 wholes and some pieces. Or maybe you use your calculator. 27 divided by 5 is 5.4, so we have 5 wholes and some pieces. Either strategy is great. Once we know that we have 5 wholes, we can think about 5 groups of 5 pieces in each whole unit. So there's 25/5. How many leftover pieces are there? There are 2/5 left over. So 27/5 can also be rewritten as 5 2/5. In terms of Math 10, it's important to know how to convert between mixed numbers and improper fractions because we use different approaches depending on what unit we're in. If we're talking about measurements or designing something or buying, generally we talk about mixed numbers. However, if we're doing calculations to solve an equation, we're working with some algebra or some slope, it's more appropriate to use improper fractions. And when we're doing those calculations, it's also worth noting that our final answer should be in lowest terms.